Good day, students. Welcome to math.serve.com. And this clip we're going to be going over quadratics. We're going to be looking at how to find the properties of quadratic functions, how to graph them using those properties, and how to find the domain and range. If that sounds like what you're looking for, don't forget to hit the like and subscribe button. And if you want to gain access to our entire collection of tutorials, you can visit our website at math.serve.com, or you can take a look at the links in the description below. The instructions for the example we're doing is as follows. We are to find the properties of the given quadratic. That's the first task, is to find the properties of the given quadratic. And then we're to graph. We're going to sketch a graph using the properties. And finally, we're going to state the domain and range. State the domain and range. Alright, so let's say we're looking at the quadratic function y equals x squared minus 4x plus 2. Alrighty, let's start by taking a look at what some of the properties are. We're going to start with the opening. Okay, let's take a look at that. Now, in order for us to figure out what the opening of the quadratic is and other properties, we need to know what a, b, and c are. Okay, so for the quadratic function, we have y equals x squared minus 4x plus 2. Now, can you determine what a, b, and c are? If a quadratic function is written in standard form, a is the coefficient of the second degree term, b is the coefficient of the first degree term, and c is the constant or the coefficient of the 0 degree term. Alright, as you can see, this is c right here, and b is negative 4. Now, what is a? There's no number here. So it's the invisible coefficient, okay? This invisible coefficient is 1, so our a value is going to be 1. Let's put that to the side. A is 1, b is negative 4, and c is 2. Alright, let's take a look at the opening. Now, if we want to find the opening, all we just have to do is look at what the sign of a is. Alright, sign of a. Is it positive or is it negative? That will tell us what the opening is. In this particular case, a is 1, which is a positive number, which means the parabola opens up. Okay, so function y is a quadratic function or parabola that opens up. Why is that the case? It opens up since our a value is positive or greater than 0. Okay, so we have a parabola that looks something like this. So just think about it as a mood scenario. If someone is positive, they're always happy on the inside, right? And then negative people are always sad on the inside, right? So the opening of the parabola is associated with the sign. And then just remember, positive, open up, smiley, and negative opens down, sad. Now, let's take a look at the next property we're going to be using today, which is the axis of symmetry. When you look at the word axis, you think about a line. And then when you think about symmetry, you think about identical images on both sides of the line of reflection. So axis of symmetry is basically the line that splits the graph of the parabola evenly down the center. Alright, so how do we find the axis of symmetry? To find the axis of symmetry, we're going to use the formula x equals negative b over 2a. Okay, and this can be derived from the quadratic formula. If you take the average of the two roots of the quadratic formula, you'll end up with this equation for the axis of symmetry, because the axis of symmetry is always right between the two roots of a quadratic function. Okay? All right, now let's go ahead and rewrite the formula. It's x equals negative b over 2a. And we know what a and b are, right? Let's write it again. Remember that a is 1 and b is negative 4. Now we're going to substitute these values into our formula and calculate what the axis of symmetry is. Alright, so x equals negative. Now we're substituting a negative number. Always use parentheses to avoid making sign errors. Divided by 2a, 2 times 1. So we're going to use PEMDAS. Please excuse my downsally to simplify this arithmetic expression here. Minus times minus is plus, so we have a 4 in the numerator divided by 2. 4 over 2 is 2. So our axis of symmetry is the line with the equation x equals 2. Alright, the next property we're going to find to help us draw the graph is the vertex. Okay, so what is the vertex of our quadratic function? Well, let's figure it out. Now, to find the vertex of our quadratic function, we are going to be using the following formula. So the vertex is given by the formula negative b over 2a, comma, a function, or we're using the y notation. You can use y or f. It's the same thing, okay? So we're using the y notation here. So it's y evaluated at negative b over 2a. All right, now freeze for a second here. Does this negative b over 2a, does it look familiar to you? The answer is yes. It's the axis of symmetry formula. So the x-coordinate of the vertex is basically the same as the axis of symmetry. They fall on the same line. Okay, so the vertex falls on the axis of symmetry, which is something to keep in mind. Okay, so what is the x-coordinate of our vertex? Let's call it x sub v. The x-coordinate of our vertex, as we can see here, is negative b over 2a. We have already done the computations previously when calculating the axis of symmetry. So we just input that answer here as 2. Now, the y-coordinate of the vertex involves more work. We have to evaluate the function at negative b over 2a. Okay, so it's going to be negative b over 2a is 2, so y evaluated at 2. Now, what does this mean? We remember what y is, right? Y is the original function. Y equals x squared minus 4x plus 2. So y of 2 just basically means we're plugging in 2 into all the x's we're substituting. So we're going to have 2 squared minus 4 times 2 plus 2. Let's simplify that. 2 squared is 4 minus 8 plus 2. Now we're going to use the order of operations to simplify this. Please excuse my dear Aunt Sally, we already started. You do exponents first, right? So this is the question. Do we subtract first or do we add first? If you take a look at PEMDAS, please excuse my dear Aunt Sally. Which one do we do first, my dear Aunt Sally? Well, the correct way to write PEMDAS is please excuse MDAS. Alright, most students would think, oh, if you look at PEMDAS, you add first before you subtract, right? But PEMDAS basically tells us that you add and subtract the same time, okay? You add and subtract the same time, but you do it from left to right, whichever one comes first. Also, multiplying and dividing, you do them at the same time but from left to right. Alright, so just keep that in mind, especially when it comes to multiplication and division. This is where most students make mistakes. They think, oh, you always multiply first before you divide. That's not the case. You multiply and divide exactly the same time, but you do it from left to right. Addition and subtraction, you do it at the same time, but you go from left to right. So let's follow the order so we are consistent here, okay? So 4 minus 8 will give us negative 4 plus 2, and that is negative 2. All right, so now we know what our vertex is. Our vertex is x coordinate 2 comma negative 2. All right, the last property we're going to be using for this presentation is the y-intercept. In our next presentation, we're going to be adding an additional property, which is the x-intercept, and that involves factoring the quadratic polynomial and finding the roots using the factors. All right, so stay tuned in order to gain access to that presentation. Now, let's go ahead and find the y-intercept. So for the y-intercept, we're going to use the following formula. Well, there are actually two formulas that you can use to find the y-intercept of a quadratic function. You can use the formula 0, c. So the c value is basically your y-intercept. It's very easy to use this formula when your quadratic is in standard form. But in other forms, for example, the vertex form or the factored form, you might want to consider this formula 0, y of 0. All right. So y of 0 helps you to find the y-intercept, basically setting x equal to 0. We're going to use both methods here, and then you see that they're exactly the same thing, okay? So in this problem, we need to remember that c has a value of 2. So that automatically tells us that the y-intercept, which is 0c, is 0, 2. Okay? So with the standard form as indicated earlier, you can easily see what c is. Now, for other forms, you can also use this formula. This one works regardless of what form you have. 0c, 0, y of 0. Okay? So for this one, you have to find what y of 0 is. Y of 0 is what you get when you plug in 0 into the quadratic function. The quadratic function again is y equals x squared minus 4x plus 2. When you plug in 0, you have 0 squared minus 4 times 0 plus 2, and your the y-coordinate of your y-intercept using order of operations, 0 minus 4 plus 2 is simply, so we have 0 minus 0 plus 2, because 4 times 0 is 0, and then our answer is going to be 2. Okay, which is a c value here. It's easy to see in this form, but in other forms, this method is really effective. So the x-intercept 0, y of 0 is 0, 2, which is exactly what we have over here. All right, now let's go ahead and graph the function. So we're going to be making use of all these properties that we found right here. So let's go ahead and figure out what quadrant the vertex lies. So it's 2, -2. Which means we're going to go 2 units to the right and 2 units down to find the vertex. So that's going to be in quadrant number 4. So we're going to make quadrant 4 sufficiently large to compensate for the location of the vertex. All right, so let's go ahead and graph it. We're going to start by graphing the vertex. So the vertex is at 2, -2. So let's call this 1, 2, so that's 2 right there. And then -2, go down 1, 2. So this is -1 and -2. So our vertex is located right here. All right, the next thing we are going to graph is the let's graph the y-intercept. The y-intercept is 0, 2, so 0, 2 is going to be right here. So this is 1 and this is 2. So right here is your y-intercept. Might as well just label it while we're at it. So this point we just found right here is your vertex. And your vertex is 2, -2. And this point right here is your y-intercept, which is 0, 2. Okay? Now we can go ahead and graph our axis of symmetry. Let's graph that. Let's make that, let's see, make it green. So our axis of symmetry is the line x equals 2, so it's a vertical line going through the x equals 2 value. All right, so that is our axis of symmetry. All right, so this right here is your axis of symmetry. And that's x equals 2. All right, so we need one more point to graph our parabola. So do you know where another point that we can find on the parabola is that can help us to draw the graph? Using the information we have, can we determine implicitly where the another point on the parabola will be? Now let's take a look at this. For example, this is the axis of symmetry, and you have a point 2 units to the right. 1, 2. If you have a mirror and you have a point 2 units to the right, what will that mirror do? It's going to reflect the same point in the opposite direction. So if we have a point here and this is the mirror or axis of symmetry, we're guaranteed to have another point 2 units to the right. 1, 2. Bam. So this is another point that's guaranteed to be on the parabola since the axis of symmetry is x equals 2. It splits the graph into two identical parts. Okay, so just going to go ahead and connect the dots, and that will be the graph of our parabola or quadratic function. Alright, so this is just a sketch, nothing too fancy, of our parabolic curve. Now we're also asked to find the domain and range of this function. So let's go ahead and find that. The domain. The domain is basically the horizontal span of the graph. How wide is this graph? This graph goes infinitely in the left and right direction. So if you have that tilt right here, it means it's going to just keep going to the left forever, and then this will keep going to the right forever. So it gets infinitely wide. And what we're doing is we're projecting it upon the x-axis. So if we project it upon the x-axis, this graph is going to be going infinitely in both directions. Okay? So remember, the horizontal span of the graph represents your domain. All right? So let's go ahead and write down what that is. The domain is going to be, you're going to the left forever, from negative infinity, to the right forever, to infinity. That's your domain, using interval notation, or you can also write it as the set of all real numbers. You can write it like that, or just write all real numbers. Now, what is the range? The range, ladies and gentlemen, is the vertical span of the graph. How high can you go and how low can you go? If you project the graph on the y-axis, we see that we go as low as 2, and then we just keep on going up and up and up and up and up forever. Okay, so what's the range going to be? You go from negative 2, sorry, not 2. You start from negative 2 and you go up forever. For the domain, we were on the x-axis, right? We're going to the left forever and then to the right forever. That was our domain, right? But for the range, we're going up and down. We're now going vertically, starting from negative 2 and going up forever, because that is the vertical span of the graph. How low can you go and how high can you go? Using interval notation, we go as low as negative 2 and go up forever, from negative 2 to infinity. Or you can write it using inequality notation as y is greater than or equal to negative 2. Okay? So let's go ahead and check our graph real quick. We're going to check our graph, the accuracy of our graph, using our Desmos graphing software that is available for free on the internet. Alright, so we're going to go right to desmos.com, and we're going to enter the graph. Just a nice way to check the accuracy of whatever graphs you generate using using the computer. Alright, so it says start graphing. You can also download this application on your mobile device so that you can easily graph different functions even without internet connectivity. Okay, so we have y equals. Now you can hit x and the caret 2 to get to the exponential field, or you can just click on the keyboard button is somewhere to the left. It doesn't show on the screen. The keyboard is to the lower left corner, and then you can use the exponential feature or just the square feature. Okay, so square squares it, or if you have other exponential values that you want to enter, like the third power or fourth power, you just hit this button, a to the b, and then it gives you access to the exponential field, and you can specify whatever exponential value you would like to indicate. So we have x squared minus 4x plus 2, and there you have the graph of the quadratic function. So the plottable points, let's just click on that. This is the, well, we just graphed the vertex, right? We graphed the vertex and the y-intercept. This is another point that we use, but it's not graphable. This is, as you can see, is 4, 2. That was the one we did with the reflection. So let's go ahead and take a look at how this graph compares with what we have in our solution. All right, so if we compare it, we see that the vertex is at -2, -2. 2, -2 is the vertex, and the y-intercept is 0, 2. So our answer is perfectly correct. How about if you do not have access to a graphing to a computer, but you just have a graphing calculator, let's say the TI-83, for example, and you wanna graph your parabola just to check your work. Okay, so all you do is you click on the y button right here, y equals, and then you just enter the quadratic function that you're trying to graph. Let me clear out what I have here. So clear everything out. Clear that, and then we're going to enter the function, which is x raised to the second power. So we have the variable button here, x, t, theta, and n. So just press it. The default setting is x when you're on your function mode. Okay, so square, you can either use square right here, or you could use the caret button as indicated earlier. That arrow, x caret 2, is the same thing as, I turned on the alpha button, turn that off. X caret 2 is the same thing as x squared. Okay, minus 4x plus 2. Okay, I'm going to zoom, press the zoom button because I want to do a standard zoom window. So zoom 6 will take us from -10 to 10 on the x, and then from -10 to 10 on the y also. All right, so there goes your graph right there, and then you can trace to see if your points are correct. So for 0, you have 2. That's exactly what we have here. And then for 2, we have -2. So that's perfect. Just look at the graph, how it looks on the calculator, and it harmonizes nicely with what we generated when we graphed it using the properties. Alright, so that's basically how you use the intercepts and the vertex to graph quadratic functions. Thanks so much for taking the time to watch this presentation. I really appreciate it. If you found the contents of this tutorial helpful in your studies of quadratic functions, do give us a thumbs up. Your positive feedback is very valuable to us. We'd like to know what you think about this presentation. If you have any questions or comments, just post it in the comment section below, and we'll be more than glad to respond. Don't forget to subscribe to our channel for updates to other great math tutorials such as this. And if you would like to gain access to more support resources, practice tests, worksheets, formula sheets, visit our website at mathgotserved.com. Thanks again for watching, and have a wonderful day. Goodbye.